anyone want to share their experience where they faced a major performance issue in their app and how they fixed it? Anything, like even if they didn't fix it, just if you can share your experience.
So I was working on a project in React.js, and there was a lot of issues with the load times. So we guys did code splitting. So that was really helpful in decreasing the load times and increasing the performance for slower internet connection devices running at 3G.
Okay.
Yeah.
That's great. So anything more?
One more thing, I've not really performed it, but I've read in React it is preferred to use memoization to increase the performance. But I'm not really sure how that really works. I never really tried that in production.
Yeah, we should talk about that in this discussion.
All right.
Anyone else? Sanket, if you're talking, your mic is off.
Sorry. So what I was saying is that we have two parts, like what Vinay said. The first one is the load time of the app. That can also be considered as a performance issue. The second, once the app is loaded, in the runtime there is an issue, like slowness of the app. Then that's like a second type of performance issue. Right. So two categories.
Right.
Okay.
Do you think we should start now or wait for more people to join?
I think it's a good open-ended question. We can continue that for another 5 minutes.
Okay.
Yeah.
Okay. So for the new people who joined, I'm asking whether you have faced any performance issue in your app, and if you fixed it, how you fixed it. You can just share your experience.
Mm-hmm. I'll share my experience. Okay.
Yeah.
Since nobody is speaking. So I have faced a lot of issues in performance. I mean, not with BuilderX specifically, but before BuilderX as well. When I was working with Angular 1.x, there was a huge performance issue because it used to slow down with the number of elements on the screen. So there were two types of performance issues in the runtime as well. One was which was being caused by Angular that watches for any variable change, runs its digest cycle. That was causing some performance issues. And then second, number of DOM elements is directly proportional to the performance of the app, right? Because on every mouse move, it needs to track all the DOM elements, its XY position, and where the mouse is, right? So I faced that a lot in Angular 1.x.
Yeah, I remember I also worked on Angular 1, but I think I didn't work on anything complex, so I didn't face any performance issue. But I remember that it was very easy, to get started on Angular 1.
Mm-hmm. Yeah.
It was a good experience.
It's something which looks very tempting on the outside.
Yeah.
It leads to something really complicated later. I mean, This is what happens usually, but yeah.
Mm-hmm.
Anyway, so front-end performance is one. We are also going to talk about back-end performance, Himanshu, right?
Yeah.
Okay. Probably we can throw that question. What does performance mean, right?
Okay. So as Sanket asked, what does performance mean? Does anyone want to add their answer? Or let me reframe that. When do you say that your app is performant?
Go ahead, Vinay. You have unmuted your mic, right?
So it depends. Like if you're saying in the front end, it's all about loading your application really fast. And even on the application side, if you're working on the mobile side, it depends how quick your application loads, how quick your screen transitions, how quick all the animations are working. If you talk about the website, then I've said it depends on how the working is going on and how the load times. And for the backend, I don't really have much experience with the backend, but I guess the performance would be like, resolving all the APIs quickly as possible, fetching all the data, or posting and storing all the data at the backend as soon as possible. That I think would be the point for the backend
Yeah,
in terms of performance.
good points. Yes. So basically, the user should have a good experience using your app. They should have a smooth experience, you might say.
Yeah.
Right. Anyone wants to add any more points? Okay. So I think we should start, Sanket.
Yeah, go ahead.
Yeah. Okay. As Sanket said, we are going to talk about front-end and back-end performance. So first, we'll start with the front-end performance. So the first thing we want to discuss is the types of performance issues that you face. So as Vinay said, there are a lot of things to consider if your app is performing good or not. So one of them is page load speed. And one thing is how smooth are your animations or transitions. Anyone wants to add more things? What are the different performance factors, like different kinds of performance issues that users might face?
Multiple re-renders, like
Yeah, that's from a developer point of view. So that means in general, if you say that in terms of user experience, then your app might feel laggy, right? And maybe the user interactions are laggy. So for instance, if you press a button and between pressing the button and getting a feedback, there is a significant delay. So that means it's a performance issue, right? Okay, so these are the different kinds of issues. So the next thing we want to discuss is how to measure these issues and how to identify these issues. So you might have your app getting slow when you're doing a specific interaction, but how do you know like what is exactly happening? What is that issue? So when you notice some performance issue with your app, what is the first thing that you do?
reload it multiple times and see if we can like figure something out.
Measure, right? I mean, measure.
Other than that,
In the website development, you can probably check in terms of React. We have React Profiler that is really helpful to measure the performance. As well as Google also provides some audits. So you can run audit to check if your application is running perfectly on mobile or desktop. So it provides you a score on which there's kind of a detailed report based on which you can kind of debug how your application is not working properly.
right? Those are great tools.
Or put it on production and wait for the end users to report it.
Yes, I'm saying if the user reports it and then you want to know what is the issue.
Right. So the question is, how do we debug?
Yeah,
How
basically, yeah,
now it is performant from a purely metrics point of view.
right.
Okay.
So yeah, we use different kinds of tools. As Vinay mentioned, we use React Profiler, React Dev Tools. Anyone uses any other tools?
Console.time.
Console.time, yeah, that's one way. If you
That's-
want to measure it on low level.
Yeah. So that's for the front end, this thing, right? For the back end, I would do maybe ping a space a website, or maybe load a website and see how long does it take. What is the what do you call that? The time delay the server takes, the network latency.
Yeah, latency and the delay in response. Right. Yeah, for front end, I think we mostly use the Chrome profiler. because the React Profiler is very good tool for debugging the performance in React. But if you want to like have a generic debugging tool and want to measure everything, so the Chrome Profiler is a great tool, I think. So do you guys use it, Chrome Profiler, and like how is your experience with it? Again, no one. Vinay, would you like to add something?
I've not really tried that. I just tried running the audit, which I present in the Chrome Dev Tools. So it's really helpful. Like apart from even listing the performance issues, it also tells you like if your user interface is good or not. So let's suppose that the color combination that you're using, all that's not a part of performance, but it tells you if the contrast is readable enough for people with disabilities. So it's much more that I'm talking about audits.
Yeah.
And let's suppose that you have missed on some important props such as alt tag in the image for the screen readers to work properly. So even that thing, minor code related thing, it even points that out.
So that is audit, I think. Let's just talk about performance right now.
Yeah.
So I think let's put it this way, Himanshu. I think let's get more people to answer. So how many of you have worked with animations? Has anyone worked with animation? I can see Ruchika, you have worked with animation. Rishabh Karnath, you have also worked with animations, right?
I will join from here.
Yeah. So Ruchika, what is the metric that you look for when you're animating things? Like a performant animation. When do you say it's a performant animation?
Okay. So mostly I will look for the smooth controller, like what are the capabilities it will give me to perform the smooth animation. Like for the animation, mostly I'll go with the if there is any scroll animation, then I'll go with the scroll controller. Like instead of manipulating adding our own controller, I will take the already controller that already we have. So I'll try to manipulate those to achieve the the native animation, because those widgets are totally linked with the native codes. So it will give me the high performance issue with these things.
Right. Okay. So the question is like, when do you say it's high performant? When do you say that your animation is working well? It's not lagging. Do you have a metric for that?
Yes, actually. The better we have called details. So they give you some graphical representation of your thing. So if you talk about it, a typical mobile app has
sorry to interrupt. Your voice is very low, I think.
Yeah. Hello.
Other people mute actually. Whoever is not saying.
Yeah, I think Ruchika, when I can mute your mic.
Hello.
Now you can go ahead.
Is I'm audible?
Yes. Yeah.
Yeah. So what I'm saying, if you talk about this typical mobile available in general in the market, their refresh rate is something around 60 hertz. That means rendering of each frame will give you around 16 millisecond of a time. Okay. So if we have something called dev tool in the Flutter that gives you graphical representation of rendering of each frame, the time taken to rendering the each frame. So if it it's give if it is rendering below the 16 frame millisecond of time frame, so it your app is performing good, your animation and whatever you have done in there, it's going good there. But if takes more than 16 millisecond, that means there is something called jank in your app. It means you have something called performance issue in the app.
Correct. So that's the metrics I was looking for, right? So quick physics fact. So 60 FPS means 60 frames per second. Why do you 60 frames per second? That makes it performant. So the way we look at the things, it's like how is animation made? So animation is a set of frames, what you see, and if that those frames are run at 60 frames per second, then you feel that animation is really nice. Remember, we used to do that animation in our notebooks, like draw one circle on each page and then move it. If you do it really fast, then it feels like the ball is moving, right? So it's that 60 frames per second, and that boils down to 16 ms per frame. So anything, if one frame calculation takes more than 16 ms, then it becomes less than 60 fps, and then you feel that your app is glitchy. So anything that needs instant feedback, it has to be processed under 16 ms on anywhere, like on television, in real life. If I move this mic at like say 1 millimeter every 1/60 second, then it will feel like okay, it's animating, but I can do it in steps. Nobody will know, right? So something like that on the very basic level, physics and all those things. All right, so that is instant feedback. That is for the front end application. It can be for animation. It can be for React app. Can you talk about backend performance and all those things?
Yeah, I think the backend also, we have the same thing, right? The more throughput you can get from your request and response, the more the server performant is, right?
Mm-hmm.
So the same thing is like when you have to give, when I say like 70 ms per request, right? So that means like you multiply it by something, right? So 800, like 8 to 10 requests per second, right?
Right. So 70 ms is the latency you are saying, right?
Not latency. That is the execution time.
Execution time.
Execution time.
So if we want to animate something from Laravel on every request, then it's going to feel like glitchy, right?
Yes, always.
And that's why we have front end. Otherwise, we would have had everything in the back end. Right?
So generally, like there is a very good logic behind that. There is something in your system that is called as GPU, right? And you have the memory buffer, right? Why those things and the screen, right? How your screen renders your things onto your computer, right? And you know, like most of these screens of the 4K are generally 60 hertz, right? So, and you have a memory area to write it, and then it updates onto that, right? So the same application, like when you are writing an application, you don't need to always update all the parameters of the application. You just need to update some of the pieces, and then you can make your application more performant by writing those into your graphics pixel directly, right? To make it more smooth, I would say. So you have to build out the caching system. You have to build out all your infrastructure such that like the changes are written to the memory, and all your requests are directly being served from the memory itself. So there is an interesting tool which is called as what is that called as Warness cache, right? It is one of the engine which actually stores all the page requests into the RAM itself, right? And when you have a spike in your traffic, everything is served directly from the mem cache or the memory itself, right? So you make that performant, right? It becomes like less than 5 ms after that.
Less than 5 ms of execution time.
Right?
So
you can save your compute cycles based utilizing those areas. So you will have to write the same thing, right? Wherever you are spending more cycles. So generally, like the 70 ms request time for the Laravel is when you are executing the entire life cycle, right, from end to end. That takes 70 ms.
Right, makes sense. So request response is one thing, streaming is another.
Yeah.
Right. Streaming is
so like generally from your computer, there is a latency to the reaching to the server. So generally our servers are in Germany, and an average from India, the latency is around 150 ms, right?
150 ms.
Yes, okay. 150 ms. Like the data packet which can reach to that server, that is called as latency, right? Even if you send 1 kilobyte of a data or one single character, it will take 150 ms to reach that server.
It will take 150 ms to go and come back. Right? The request and response.
Not request, only one side.
One side is 150 ms. Response will take 150 ms. Right. So 300 ms is 1/3 of a second. Right?
Average, right?
So if I want to say rely on backend for a button click, right, and I want that to be really performant and rendered from the backend.
So you will have to delay it by 250 ms, right? At least like 300 ms.
300 ms. So that feels glitchy for me, right?
Obviously, so like you don't have to do the fronting stuff. You don't have to send it to the Germany location. Yeah. The other option is like host your server to the local host, right? Make that latency as 0.
No, but for the user experience, I'm saying like if I want the entire, say forget React, I want to get out of front end development. I want my every action on my page to be rendered from the backend, right?
Right.
So in that case, I can't really rely on these servers, and that's why we have a front end layer.
Right. That's true, and that is the display layer. Like I would say,
okay,
for the web application on any of the application which is an internet-based application, right? The major part is the internet-based applications are meant. The front-end part is your monitor, right? And the CPU is your backend, right? Where you are sending data change requests to your front-end layer or your React application or something to go and update the view of the user to make it.
And that's why there's a need of front end and back end, because front end is very intuitive and fast.
Yeah.
It can react quickly.
Yes. And so that's the combination, right? The browser is your monitor.
So I have a question for I think Himanshu and people, all three of you, or maybe anyone. So I can think of, say, Counter-Strike. Counter-Strike is a combination of both, right? Like we are playing games and it's also doing a lot of things, right? In the, like, if I shoot someone and if it takes 150 ms, that's not real, because it in real life it will take like really less time. So how does that work? Like games like
all the games has a latency bug, and many of the developers or many of the gamers, they take advantage of that.
Latency is there, but what I think is first they mutate their side of the state, I think, in the front end itself, and then they sync it to the server, maybe. That's what
so what you can do is you can do a predictive acceleration, right? So say an object is moving at an x speed, so you actually send the acceleration or the speed of that object, and you predict into the future to reduce your latency, right? So you say this guy was moving already, so when you are sitting on your screen, you are actually simulating to the most real value, nearest value.
Okay, I think that is handled. That because 300 ms of latency would cause a lot of glitch. In Counter-Strike, it's like every second people move by 10 different locations, right?
Yeah.
Like it's very fast. So it must be doing some sort of predictive analysis.
Yeah, so I think like prediction into the sense of like what is the next move the user, or if they are running into one direction, the direction itself is positioned, and the 300 ms gap might be have calculated as an advance for the end game player.
Right.
So when you fire a bullet, right, that hits to the right target, not missing out by 300 ms.
Yeah. What is the word for that, Himanshu? Which updates the front end and then updates the back end?
I don't know if there is really a term.
Optimistic updates, right? Optimistic updates, I guess.
Okay, that's new for me. I don't know.
Aditya knows it, I guess.
Okay.
Yeah.
All right. So we are doing this in API beats. So we are updating a lot of things in the front end and then later saving in the back end. And if the backend fails, then it again updates the front end with the latest value from the backend.
Yeah.
Mukul was writing something. Mukul, you can explain that?
Yeah, I was thinking about like if we predict it, then it will cause lags. Like we have already moved the person to front, but he has changed direction on his computer. Like the person who is playing, the second person. So it to the first person who is viewing the second person, he will show him at the other place, and actually he will be at a different place. It will cause lags.
It does. I think it does cause lag. But if the person is sitting right next to you, the latency would be like 1 ms or 2 ms, so you won't notice. If someone is in Germany, even if you are on phone call, you'll have the same latency, so nobody knows what's going on, right?
But I agree with Mukul that all the movements might feel laggy. It's like I'm running towards some target and I'm changing directions frequently. I can change it within a fraction of a second, and if that is the case, then
I think it chooses the nearest server to do that prediction. But still, if you are in like really far locations, that latency has to be there. You cannot really escape that. It's at the speed of light, more or less.
Yes.
Yeah. So you can't really ignore that. But
so the light takes around like the fiber optics. What is by most of the ISP, when you buy a lease line connection, they say from India to US, I will give you a latency guarantee of 230 ms is the best what they can do.
But these servers are also really optimized. When you connect to these game server, if you're just playing with a person in the next room, it uses LAN. It uses like less than 1 to 2 ms. If you're playing with a player in India, the latency is like 7-8 ms, something like that, right? And you can't really make out with what happens with a person on the other side of the planet.
Yeah, so Nitish is saying the regional server, right?
Regional servers,
Yeah,
right?
regional servers are the way.
But anyway, I think we are talking too much about game, but that's a good thing. Let's talk about Himanshu. Let's talk about the acronyms, like the words, and let's go over the usual way of debugging things in the front end. Like profiler was one thing. What else do we need to look at?
Yeah, for front end, yeah, I think we use profiler, and other thing, as Ankur mentioned, we use console.time. So those are really low level things. So when we notice that some in the profiler, when we notice that some function is taking this much time, so we can do micro measurements using console.time. So that also helps. And I think, yeah, the other thing that so apart from the runtime performance issues, what we need to measure is sometimes if the page is slow, we can measure the page load speed. We can use network tab for that. So we see if the assets that we are loading or the page that we are loading, how much time does it take, and if it is really a backend issue, or if the backend is giving us the response in expected time, but we are somehow loading it slow. So those are the tools that we need to use there. So for backend, I have a question for Pratik. So if, let's say, we have a response time of 200 ms from an endpoint in the server, so how do you debug that? Like, what is actually taking that time?
I'm actually about to share my screen. I'm just logging into one of the console, what I use, right? I can share directly with you guys how it is being used. Yeah. So there is a very good tool for performance analysis and debugging, right?
Wait, I'll share
your window.
I'll share it with this one, the camera.
Okay. So here is something called as APM. I don't know how many of you have used it. It's an application performance monitoring, which is called as. You can use backend as well as your for front-end application as well. So I have just deployed it for 3 of our servers. And this actually gives me a very good report. I'm just going to New Relic. New Relic is the product name. APM, application performance monitoring. There are different tools of the application performance monitoring. I'm using New Relic right now. So this actually gives you a currently production servers data. So there is a daemon running at the server for the New Relic, which actually keeps capturing all the request information about your code, what different kinds of services it is interacting with, right? Over here, you can see what are the different transactions it is taking, how much time it is going to take. Even you can, if you have to debug further, you can click onto that function, and actually it goes inside the code and tells you more about that, what kind of a method it is being called, right? And what is the percentage of time it is spending onto that. Even most of the queries, like if you are running a slow SQL, you can go and dig out about all your these things, right? So I know all the SQLs are okay. There is an external service. We are actually storing the files onto the S3. It is taking around 85 ms, 88 ms to store, right? So this is my tool for debugging quickly onto the production environments to monitor how the system has been performant, how the things has been going on, right? And you can actually go and check into all your SQL queries as well. So it gives you a complete SQL analysis as well, because you interact with a lot of other services, right? So how many times these SQLs are running? What is the throughput of the SQLs running, right? So this gives me a very good graph of data, and whichever your controllers are calling, whatever percentage of the web requests which are coming in, it gives this a complete analysis onto that. And this really helps me to analyze, okay, the problem is at this point, not at a particular some other places. Ankit is going to play something up.
Suraj, we need to fix project controller store poll method. This is really this is a nice tool. We have been using it for a month now, I guess.
Yeah.
And like a lot of optimizations are going on in BuilderX and API beats both.
Yeah. Also, this gives us a very good information about all the errors as well, right? So it keeps tracking of all your crashes of the system. If anything has crashed recently, in last 30 minutes there is no crash, I will just jump into last 3 days, right? To see how does it perform, right? So I know now that there was an error somewhere over here, right? At this point, there was an error, and this was one of the most errors which are coming in from the servers, right? You can click onto that and you can actually see a complete trace of this code as well. All those things like which is tracked at the production level, this is handled async level, right? It is not going to hold your request at that time, but it keeps pushing all the process details into the New Relic domain for all the information. You can have a complete trace of all the details, whatever APIs and other things it has called in and where it has crashed, right? So this is my favorite tool right now to analyze what is happening into the server. So when I go to the web request, I can say, okay, the server is running around 80 ms the performance, and these green, yellow, and the blue lines gives you an idea what kind of services you are interacting with and how much time each of the parts of the things are taking, right? And we know that the throughput of the server right now is around 600 page requests per minute, like 491 requests per minute average.
Nice.
Right? So
on the lowest level, how do you check the latency of a server?
So generally, this is not telling me the latency of the end user. This is most of a server side execution.
Server side execution time.
Execution.
Yeah. But if we want to see the latency, so we can do something like.
So you can just actually go and do a ping method, right?
So ping say geekyants.com.
Yeah. So you're getting 55 minutes. Yes. But this is not true. So I am using a Cloudflare in between for us to serve the request from the location, which is an PN which we are using, and then the request is actually going to our. So you can write cp.southsoft.com, right? That is the actual location of the server.
cp.southsoft.com points to the real server.
Yeah, real server. So that is 160 PM.
160 ms. That's the latency to reach the server.
Yes.
Okay. How far is Germany from here? No, that's the question. How far?
I don't know. Like,
yeah.
Have to check it
okay. Just a second. So it's based on the distance, right?
Yeah, it's based on the distance of the end user. So
yeah.
The advantage of the one of the cloud infrastructures, especially with Amazon or any of the Google Cloud and other things, is you can deploy multiple web servers on your different locations altogether, and ask the the CDN servers to serve it from the nearest location.
Okay.
Right. So that's how you reduce the latency.
Okay. So 7,000 kilometers, something like that, right?
Yeah.
That's how it's calculated. So
Sanket is going to
7,000 kilometers per second, right? So per how many ms? 0.00 or 0.16. 160 ms.
160 ms, yes.
Okay.
Because it's right? Yeah.
So the speed is 43,000 kilometers per second.
Per second, yes.
Okay. Nice. Good. Yeah, I think anything else?
Yeah, I think that was one of the tools that helps me onto the backend tracing, and that is very much useful for me to trace things around very quickly. That is directly deployed onto the production level, so I keep getting all the notifications of the health of the servers and everything.
All right. Talking about a bit about front end as well, Himanshu. I think we missed a few things. Yeah. I think,
and also I just wanted to add, the APM is not just for your backend stack. You can actually integrate it with your JavaScript stack as well, your Node application as well, and your mobile applications as well, right? So you can use those APM. If each of the APM has their own SDK is available for different frameworks and different plugins. You just need to plug that into and then the application performance monitoring starts capturing it. And then you have the real data coming into your dashboard.
So do you recommend on getting away from Sentry?
Sentry is just error logging, right?
Yeah,
it is not the performance.
So this has both the things.
This has both the things. The New Relic has both the things. Generally, it is a paid product, so we are paying around $500 per month for that product, right? Just to get that information, right? So that is so expensive. So generally, when you have to make sure that if you're getting through that, then yes, I think using a New Relic kind of a tool really helps.
All right, cool.
But I think there is another product as well, Apache Skywalk, right? Skywalk is one of the open source projects which does the same level of things.
All right, makes sense. Cool. I think most of the people are working with a bit of backend and also a lot of frontend. So let's talk about frontend as well. I think when we talk about performance of web pages, we need to look at time taken for first interactivity. That's one of the measurement, and then time to render the first frame. There are 2 or 3 more different types of metric that we need to look into. But these 2 are really important. Like how long does it take for the first character on the screen, and how long does it take for the runtime JavaScript to run and the page to become interactive. And then we have like on-fly runtime performance measurement. That is
I think
60 FPS.
One of the other performance nowadays comes into the picture is like the render time of the CSS as well.
Yeah, so that's one of the things. Like first, time to interactivity has a component of CSS rendering.
Okay.
Yeah. So CSS rendering is one thing. Then we have JavaScript load buffer, like it loads the characters into the memory buffer. That's one. Then the runtime, execution runtime, like how long does it take to run the JavaScript which is loaded in the buffer.
Right.
And then the page becomes interactive. So these are all part of like the load time. Then once the page is loaded, how performant or how butter smooth your application is. Like if you move the mouse, does the page react really fast, right? So that's 3 different things we are talking about. Like first division is backend and frontend. Frontend has a load time, and then once the page is loaded, then we have like on-fly performance. That should be 60 FPS, and everyone should just try to reduce it as much as they can to make it feel more real life.
Right.
I think the async programming of the browser itself, the JavaScript was born due to that, right? Because the browser always was to allow user to view that page without blocking it, right? And that's where the JavaScript was born, to make sure when the user is clicking onto something, it doesn't block the rendering cycle altogether completely, and just pushes those changes back into the browser. That's how the invention of JavaScript was.
Yeah, but that doesn't run in a different thread, so it's
no. And the initial idea was that like the evolution of the JavaScript started because of that. So we do not want it to block the page the user is browsing, and they wanted to perform some of the actions at the backend. So they started with the implementation of the JavaScript, which was the very initial version, right? Now it has changed to a lot different ways.
Yeah, the front end has started becoming more and more complex. So
it is becoming the application interface now.
I'm going to mute ourselves. We have spoken too much.
Okay. So Sanket, as you said, the things that we need to measure for load performance are time to first paint and time to first interactivity. And the best tool, I think, to measure that is the Chrome profiler itself. It shows you those things in the profiler itself. The point where it first loaded the full page and the time where it started becoming interactive. So that's
and Lighthouse is another tool. Lighthouse and Profiler, both the things.
Yeah, right.
Okay.
And another performance metric I want to add is like the runtime performance issue. One issue is the layout reflow issue. We had faced that issue a lot in BuilderX sometimes. So that issue happens when the layout is being recalculated again and again. So you need to minimize those layout recalculations. So those issues are also shown in the Chrome profiler itself. So when in your stacks, the call stacks that it shows in the performance tab, it also shows this layout reflow in different colors, so you can really identify those things when it is happening. So I think that really helps. So I think, does anyone else want to add more about what other kinds of issues that we want to measure or identify? I think we have covered many of them now.
Right. I think, do you guys use web worker for caching out the browser pages to make use of those caching? I don't know if we are using it still. That's one of the features which was added to the browser.
Service worker?
Service worker.
Service worker, right?
Yeah, we use it for basic caching, just for caching our assets.
Okay.
Like when you drag an image, if we are changing something, like even
So
if you
you guys
drag
are
it and
using it.
re-render it,
Yeah.
it used to make network calls for fonts and everything.
Right.
On every mouse move. So we have like cached that in service worker, so it just remains in the front end.
Okay. I think you should look at the Cloudflare service worker.
Mhm.
So Cloudflare what it says is like we build the service worker at our end. So when they start booting your application, they will inject those things from their own service workers without calling their backends.
Yeah.
Right?
Mhm. Makes sense.
So I think they have a new API on that. I think you guys should explore into that.
We even need to add it, like if the users, they already have loaded a version of BuilderX, they shouldn't request again unless we change the version number.
Right.
We'll add those things. Yes.
I just remembered because
Yeah.
I was looking into the Cloudflare. They have their new article coming up
Okay.
for those things.
Okay. What
Okay.
else? Yeah.
So does anyone else have? Does anyone has to add anything? Any more tools to measure performance? Any other tools that you use? Like let's say for mobile apps, do you use anything else, like for web apps? We just use the profiler mostly.
Vinay has something to share.
Something to check.
Vinay.
So in React Native, we have a performance monitor. A week back, I presented a tech talk on how to make animations as smooth as possible. So not really much. It's not really complex, but you just get a small view in which you have the description of how many frames are being used in the native side and the JavaScript side. So like you want to keep the animations as much smooth as possible on React Native. So what you can see is no matter how much JavaScript thread is, so you need to maintain like the UI thread that's running on the native should always run at 60 FPS. So in order to monitor those things, you can use that.
Okay, right.
I think Flutter has a really nice debugger, and the profiler of Flutter is also really good. And now it's integrated with VS Code, so you can get all the metric inside.
I think
VS Code.
like one of the things that is for the development purpose, right?
Mhm.
I would say like APM, everyone should look into their specific APMs. When you push the code onto the production and still you want to get the profiler to have the actual real users performance, right? So I think APM comes really handy into measuring those things. Once you have pushed your application to the production, right? It still keeps capturing all those data points for you, and that helps you a lot into getting your application or next version right into those directions.
Right.
Yeah. Yeah, it really does seem like a great tool. We'll try that. Okay. So.
Nitish has a question, Himanshu.
Oh. Okay. So for the web, which would be more performative, all the DOM structure or directly rendering the canvas, which Flutter Web does? Okay. I think Canvas does have a good performance, but we faced some issue with like, I don't know about a general issue, but in BuilderX we faced a specific issue where the canvas size was very large and then it was very slow in that case. So I'm not sure if it fits all the cases, and maybe it's just a hack. But like the DOM has a first-class support in browsers. So
no, but it depends, Himanshu. I think Canvas is usually more performant compared to DOM, because DOM comes with a lot of its own event and event bubbling and a lot of objects per layer, right? Which most of the people might not need. Like in general JavaScript application, you might need just say you want to have a div with text and just want to capture say on mouse move, right, or on mouse over. Canvas just has a plain bitmap area, and you can it doesn't have the bloating of DOM, and it's usually very performant if you just use it right. We went wrong with the way we used in our experiment, because we were using Canvas for a much larger area than the screen, and we were scrolling through that. So every pixel on Canvas uses some memory, right? So that was not a good way of doing it. We should have implemented scrolling inside Canvas. So just have the render size as many pixels you want to see on the screen, right? So
also, like, I think the advantage of using a canvas is like you can actually switch it to OpenShell at any time, right? And you can use the actual graphics card of the GPU if it is available, and then you can run too many computation at a faster pace.
DOM has all those things, but it comes for a cost. DOM has all those like GPU acceleration. Like if you use CSS3 animation, it uses GPU. Nitish, coming back to your question, Flutter Web uses a combination of Canvas and native elements. So anything which is hard to implement in HTML, it uses Canvas only for that. Like I think something like drop shadow or a few things. But if you look at text and all those things, so it has started to use like native HTML, Flexbox, and all those things.
Yeah. I also think like one of the other things comes into that, like many of the places I have seen, like they have started using WebAssembly, which like processing throughput, right? And but that comes with a disadvantage, like you will have to maintain your own memory management, right? You will have to implement your own GC collectors, right? And everything has to be implemented in a well way. But that runs directly onto your core CPU to give you more performance. So I think when you write WebAssembly with Canvas, you can actually become more performant.
Figma uses that. Figma is built in C++, and it compiles the Canvas area using Canvas and WASM.
Yeah. So that's what, like, you can go away with
if you
most
choose,
of the JavaScript part. Then.
If you choose Canvas over DOM, you are anyway like it's way more lighter because you handle all the events yourself. If you want to get out of the event loop of JavaScript, then you use WASM over JavaScript. Right. All right. I need to go, so you can carry on, Himanshu.
Yeah.
I think we are all done. Like, let's
so we can
have a closing statement
and
cool. Okay, so we have some points left, I think, that we can discuss. So the first thing is we have discussed about the issues, the performance issues that we face. Another thing is, how do you fix them? So like, let's say if there is a slow interaction, so first we need to find out the reason behind that. Maybe your React component is re-rendering a lot, so you need to fix those re-renders. Or one thing is, someone mentioned, I think, the memoization, and Vinay mentioned that memoization and caching, and also Pratik mentioned that we should use service workers for that. So yeah, we use those things to reduce the time to fetch those things. And memoization is a slightly different thing, where if you just in general, if you just call a function with same parameters, it returns a stored value. It doesn't have to run again. So that's one way.
You can also use debounce.
Yeah, and in some cases, we can use debounce, where like if any expensive operation is happening, a lot of times we can just debounce it so that it reduces in the frequency. Yeah, I think Vinay has added something. Is code splitting? Okay, so is code splitting possible in a PWA?
I think generally, like people do is like they host the PWA website at a different subdomain, and they use the request coming from the browser to redirect or rewrite that URLs to the PWA website itself. That is one of the strategy I have seen many people using that.
Isn't like PW something like you download the entire web app on your device and then it functions like a native Android or iOS application?
I think it supports for the offline, but I haven't given it a real practical try, so I can't answer that really with a confidence. But I think the PW is supposed to be like that, right? So you can have an offline based support into that.
Yes, that's what
Because
it is supposed
yes,
to be like that.
I
Sorry.
actually saw a TikTok video by one of the Flipkart person, and he said like PW is something like you can download the entire web app as a native mobile app into your device, and then it will function much more like that only. So I was asking if a PW is downloaded once in your device, is code splitting or dynamic loading possible in it, or it's just downloaded as just a single bundle at once?
Even I'm not sure about that, but I think it is downloaded as a single bundle. But if anyone else has more experience with that, they can add.
No experience for me. We haven't tried that. Honest answer. Anyone else who anyone else has tried, they can come up and say about that.
Okay, I think no one has really worked with PW like that
Yeah,
much.
Vinay, let us know the results.
Yeah. Okay. Yeah. So we were talking about fixing performance issues. So are there any other strategies that you want to add to fix specific performance issues that we face?
I think one of the other things would be writing a good quality code as well, right? To make sure you are not wasting your memory, your execution cycle.
Yeah. So that gets me to the next point, I think.
Yeah.
So
Okay.
do you always like start writing code such that it will perform good in the future, or do you fix the performance later when the performance issue arises?
In my practical scenario, I do it like progressive, right? As
Okay.
we progress to the next level, we look into that, and then because the first idea is to get my things up and running, right? The
Yeah.
next is go and look into that how it can be more quality work, right? So it is always for me especially, it is always a refactor cycle after my first development.
Yeah. So I agree with that, because like the premature, if we call it premature optimization, right? When you think about performance too much when you're starting out the development, and I think it's not really necessary, because sometimes you might think that okay, like traversing over this array multiple times, it will cause performance issues, but if it's not containing so many items, then it doesn't matter really. So the readability matters. So you don't uh, need to really optimize that at that point. Maybe in the future, if something happens there, then you need to optimize maybe.
I agree with that completely.
Yeah, but having said that, you should always have your architecture such that it will the performance will scale properly.
That's true. Like you have to always write it in a cleaner design pattern. So you can go ahead and modify those particular specific functions,
Yeah.
which is more optimization. So the code is splitting and the organization of the code should be cleaner.
Right. So does anyone else want to add something here? No, no one.
No one is doing such an optimization. They are saying, I'm happy coding itself."
Okay. So you're saying you don't think about performance, everyone? Okay. Uh,
No, I just encountered a project today. So I saw that they deployed different services, like different services, including like they didn't make tables for different purposes. They made different databases and different service APIs plus the whole service. I mean to say, a whole application dependent on that table into a single service. So that by that, I guess they optimize a lot of requests where because they can use the same hardware uh, for like at a single endpoint there are less number of requests, so they use the less configured hardware there and more configured hardware where there are more processes. So I guess that was a good good way of optimizing the request at server side.
Yeah, I think Mukul, that is the strategy of microservices, right? And the microservices has two patterns in generally used at. One is called as like database per service or database per endpoint, right? You can say that. Or the other strategy is using a shared database for your every endpoint or a service, right? So I think they are using per service based database architecture with the microservice development, and that's really a very neat way of writing the code into separate services, so the scalability can be maintained at any point.
Yes, that totally was in there.
okay. So coming back to backend performance, can we talk about database optimization? I mean, I don't really have much experience with that. So if anyone does have it.
I think Aditya is doing a lot of optimization with the database.
Well, I can't say I'm optimizing it, but actually, I have learned a few lessons in the last few weeks. So there was this API, there was this SQL query that was taking 17.3 seconds, I think, and that was causing all the jobs to fail. So apparently, there are few things into SQL that you cannot do. I think that was being caused because I was getting the entire table from backend and then trying to process it. So that didn't like fail in our local servers but when we went to like production and the data was like 2 lakh plus entries, it started failing real bad. So I think one of the key features that I am starting to like recognize is that even in SQL queries, there are cost issues with everything we do. For example, we are creating if we are using join, like I think I crashed BuilderX server once. Like I think pre-development, I crashed because I was trying to write a join there, and the data was too much. So I think these are the key factors in backend database optimization as per se.
Right.
I would say like most of the database optimizations are like you need to understand what you are fetching from the database, what is the amount of memory it is going to utilize, right? When you are creating a result set, right? Also, a few of the important parameters are like having your indexes in place, right? So when you create an index, that generally any of the database that tries to keep those information always into the in memory rather than storing at the secondary storage. So it tries to keep everything into the RAM itself, all the indexes, so you can perform your operations directly in memory, right? And then you can get out the information whatever is required. So generally the most common issues I have seen in all the production environment is missing out the indexes, right?
Yeah.
Missing out the limit statement, right? Limiting your result sets to 1 to 100 to 1000, right? Which is very important, right? And then also when you have a huge size row, then you when you select specific records or specific fields, that also gives you a very much performance, because the result sets are actually when you write an SQL. So we need to understand how the execution happens onto the server side when you are writing an SQL, right? So what happens is when your SQL is written it is parsed, and then there is a memory set which is created for you, right? A memory buffer for your result sets to be stored. And then whatever query you have written it, that actually pulls out all the information from the disk and creates an in-memory data set for you, right? It doesn't, or it pointers of the data sets, right? I would say, right? And then the result set is returned to you, to your application. As you fetch from the information from your data sets, right? Then you get those information. So the SQL, the important aspect is what will be the result set which you will see, right? Is that result set enough into your memory to fit in? If not, can you optimize your SQL? If yes, go ahead and do that as a shorter version of your SQL. If not, then MySQL by default will have a limit of results it is storing. Generally, by default, it has a 32 MB or 16 MB of a per query. Whoever writes it, it has a by default 16 MB of a data storage, which is given for each result to store, right? But if that exceeds, then actually it starts creating the same result set onto the disk. And we know that the disk is like 70 times to 100 times slower than your RAM, right? And there actually your performance starts dropping out, right? Now, where it was using a quick sort into the memory, now it will use file sort into onto the disk if the result set is more than 16 MB, right? So those are the key factors as you write your application, how much memory you're going to use. The SQLs, you need to understand when you're writing the SQLs, what will be the actual performance you will see on your application, right? So if you keep looking for or keep an idea of how the database servers are going to execute this, then you will get a better understanding where to optimize your codes, right? So that is the basic idea. I would say if you start thinking on those lines, you will automatically write a starting better SQL codes.
Right. Those are some really good insights. Thank you. Okay. So the last point that I want to talk about is web workers. Has anyone here used web workers in their web apps? No one? Okay.
I have. Web worker is something that you can run a piece of code in JavaScript, right? Like if you don't want to busy or block the main JavaScript thread, is it related to that thing?
Yeah, right. So if you have an expensive task, you should run that on a separate thread. That's the general concept, right?
Yeah, correct.
Yeah. Generally, you don't need that if you're building a normal CRUD application or something. But if you're doing something where you need some kind of heavy processing in your front end, which normally you shouldn't do, but if you require that, then that should happen on a web worker. So for Builder Export code, we use web workers for code generation. The code generation part that totally runs on a web worker. So anyone else want to add more here?
But how do you, like with the web worker, you comes up with a lot of other challenges. How do you interact between the processes?
Yeah. So again, it's like you can't share memory between these two threads. So you have to use transferable objects. And again, you can't, like you have to have serializable objects that can be transferred between these two threads. So that's kind of an issue, or maybe let's say a drawback here, but it helps in some cases. Like for us, it's like we just serialize the whole object of the files that are represented as JSON in our main thread, and then after stringifying that, or like after serializing that, we send it over to another thread which just uses that JSON to generate code. So it is useful in some cases, but yeah, maybe in some cases it won't work that well.
There are some more disadvantages that I read somewhere, like the workers cannot interact with the DOM.
Yes.
It has limited access to functions and properties which are inside the Windows object. Is it?
Yeah, right. It doesn't have access to DOM, but I think that's like it's intentional maybe, because it, as I said, it's to offload your expensive tasks. So I don't see a scenario where you would need the access to DOM on a web worker.
Okay.
If you can think of any scenario like.
I don't
I
really
think-
have a scenario, but I just read it as a con.
Okay.
Yeah.
Pratik has to add.
I was thinking like that is what meant to be. Otherwise, like there will be multiple workers interacting with the same DOM element, and it can be used as an exploitation for your browser.
Yeah, that is one case. Okay.
Is there any standard package for us to write a worker like function separately, like library which?
I think there are a few libraries. I don't remember the name, but there is one library which just with which just you can just like use a function, import a function from that library and write your code within that, and it will just move it into a separate worker. So you have helpers for that. So it's not very difficult, I'll say.
Okay.
And also, if you're using Webpack for bundling, then you need to use a Webpack plugin so that it like generates a separate bundle for that worker. Because Webpack, if you're not using like if you're using normal code bundling, so it will generate a single bundle. Webpack will generate a single bundle for your single page application. But if you're using a worker, that should be a separate bundle.
Okay, so like the loading itself like is separated for that worker.
Yeah, but there is one more thing that like the web workers code can also be inlined into the main bundle. That option is also there, but people generally have that into a separate bundle itself.
So you actually start a worker and then you say load this JavaScript files from there and start executing it.
Yes.
Okay. So just like opening a new tab of the browser, but
Yeah,
just with the JavaScript code.
Right.
Okay. So generally, like for interacting multiple processes, there is a standard remote procedure call, right? Which is a protocol used for multi-processing, right? Multi-threaded communication. So I think there must be an RPC for worker thread as well.
Yeah, for worker thread, it's the same thing.
Okay.
An inter-process communication.
Okay, inter-process. So they use IPC over there.
Yeah.
Okay.
So I think I've like we have covered all the points. Does anyone else want to add something?
Mukul, you are in office?
Yeah, I got here to get that monitor.
Okay. Nice.
Okay, I think we had a good discussion. Hope really everyone learned something from it. So that's it, I think.
Yeah.
Yeah.
It was really nice to have you guys over here and getting a good knowledge from you guys as well.
Okay. Then, you guys.
Thank you. Thank you guys. Bye.
Thank you.